video, we're going to look at an example of ratio and proportion. In this particular example, you're given two triangles that you're told are similar triangles, and you're given their heights and their widths, but the width of the smaller one happens to be an unknown x that you need to solve for. So go ahead and try this problem out on your own before we take it up together. What you're going to have to do is set up a proportion that compares the ratios of, for example, the height of the small triangle to the height of the big triangle is going to be the same as the width of the small triangle compared to the width of the large triangle. That's one way of setting it up. You could also compare the height of the large to the width of the large, and that ratio should be the same as the height of the small compared to the width of the small. So again, it's up to you how you set up the proportion, but when you actually solve for x, you will obtain the same value regardless of how you set it up. So you can try setting it up several ways and verifying that you do indeed get the same value for x. The key is these are similar triangles, so the ratio that they're scaled by is the same for both the height and the width. So if one is a factor of 2 bigger than the other, well then its height would be a factor of 2 bigger and its width would be a factor of 2 bigger. So again, it's been increased using the same scaling factor for both the height and the width. That's why we're able to set up our proportion. So go ahead, try this out, hit the pause button, and then hit play when you're ready to continue. So hopefully you've had a chance to take this up. Let's go ahead and try this out together. Again, there are different ways to set this up, but let's say that the height of the large triangle compared to the width of the large triangle is the same as the height of the small triangle compared to the width of the small triangle. So again, what we're doing is we're specifying that the height of the large compared to the width of the large is the same as the height of the small compared to the width of the small triangle. Now, getting back to the proportion that we've set up, 7 over 9 is equal to 5 over x. If we want to solve for x, all we have to do is cross multiply. What we can actually do is solve for x in one step if you like, or we can just go ahead, cross multiply to get 7x equals 5 times 9, which is 45, and that means x is now going to be 45 divided by 7. Now, we had said that there are other ways of setting this up, so some alternative ways in which you can set this up. And let me just do this as a little aside. So this is an aside for the original setup. What you might have done is you might have compared the height of the large triangle to the height of the small one, and that ratio would be the same as the ratio of the width of the large triangle compared to the width of the small one. And then you could go ahead and solve this, and you would still end up with an answer of 45 over 7. Another alternative, if you'd prefer x to be in the numerator rather than the denominator, is you can compare the width of the small triangle x compared to its height, which is 5, and that has to be equal to what you get when you compare the width of the large triangle to its height. So all we've done is the exact same thing that we did originally, except we've, rather than comparing height to width, we've compared width to height, and that puts x in the numerator. Okay, there are other ways of doing this. We could have 5 over 7 is equal to x over 9, which is what you would get if you compared the heights of the small to the large and the widths of the small to the large. So again, there are different ways of setting up the proportion, but the key is at the end you will still obtain the same answer. So all of these methods presented here are indeed correct. The key is that you are comparing quantities that in fact do have the same ratio as one another.